Dividing rational expressions. So a rational expression is a fraction where both the numerator and denominator are polynomial expressions. When you have rational expressions, you always need to remember that there are restrictions if there are any x's in the denominator or the bottom. So if you want to know more about these restrictions, watch my video, Rational Expressions Restrictions. Special note, if you were given a rational expression, you always find the restrictions before you simplify. And that goes for before you divide and add, whatever you're doing, okay? And this one we're dividing, but whether you multiply, add, subtract, or just simply simplify, you find the restrictions first. For the purposes of this video, I'm not going to find the restrictions, but understand that they exist. While I focus only on the simplification of the rational expressions, please understand that restrictions exist on every one of these that I'm going to simplify. So how do you divide two rational expressions, or how do you divide two fractions? Well, you're dividing two fractions, so you multiply by the reciprocal. That's the fancy math way to say it. But the best way I've heard it, and this is not mine, this is some teacher somewhere that told one of my students that came from high school, and they said, hey, Mr. Guest, my teacher said keep, change, flip. And I don't know where they got it from, but somebody came up with it, and they're a genius. Okay? I love it. All right? So it's KCF, which is, I like chicken, so it's real close to KFC. All right? So keep, change, and flip. So KCF. Then you multiply, which is straight across, meaning you multiply numerators together and then you multiply denominators together. This is not like adding and subtracting. You're not trying to get a common denominator. You just multiply straight across. Since you're multiplying straight across, division, after you divide, right, you flip and do that, KCF, division is literally one step and then you multiply. The added challenge with polynomials is the factoring piece. That can take many forms, and any possible way that you've ever learned to factor is fair game when you're doing this, okay? And everything won't factor. You'll run into some things that you just can't go any further with, and that's okay. But you try to factor everything. So I want you to recall that if you have m over n divided by p over q, then you keep this one, you keep this one the same, all right? Had the wrong thing selected. You keep that the same. You change this to times, and then you flip this one, right? The fancy word is reciprocal for that, right? So we keep, change, flip, and then you multiply straight across. Okay? So it's literally one step and then multiply. So when you divide rational expressions, you apply KCF and then you factor. Okay? Because I don't want to multiply these polynomials together. I want to divide out common factors just like when we simplified, except these problems have more polynomials to factor, and then don't forget the KCF. Okay? So if you watch the multiplication video, I tell you just go straight to factor, and then anything in the numerator can divide out with anything in the denominator. If you watch the simplification video, that's what we start with, is just factor, and divide out. Okay? You got to have it simplified to factor it, but simplify it, factor it, and then divide out. And by simplify there, I mean remove parentheses, combine like terms. Right? I prefer, now this is a Mr. Guest preference, okay? So your teacher may want you to do something different, and by all means, if you're in their class, you do what they want you to do, okay? Don't worry about what the crazy guy on YouTube says. You do what you want to do. I prefer to leave both the numerator at the top and the denominator at the bottom factored, as this says to anyone, I know nothing else divides out. I like this of my students. I require that they have it factored at some point so that I know nothing divides out, and I know that they know nothing divides out. If you don't factor it, then I'm just like, well, how do you even know? Like you just got lucky and got it right. So you need to factor it to tell me that, hey, nothing divides out. So when I look at this, I see two fractions. And then what do I see between them? Division. That's the recognition piece, okay? Math is just like anything else. If you want to relate it to a sport, if I'm a cornerback in football and I go up to the line of scrimmage and I'm on my receiver, right? He's in the slot, and I come up to the slot and I'm covering him, and I read a go route. Because I've been studying film, right? If I read a go route, which means he's going to run straight down the field deep, and the quarterback's going to try to go over the top. If I read it as that, and I turn and run backwards, and he does a little three steps and stop and turns around on a little hitch or something and catches it, then I look pretty silly. Or maybe I read a slant, and I break to the middle of the field to cut him off, and he runs right by me and is wide open. I recognized the play wrong, and I looked silly. It's not that I'm not a good athlete or whatever, right? I mean, if you play football, any sport, you're going to be a good athlete, okay? So it's just sometimes we make mistakes. We read something wrong. It's the same thing with math. If I read this problem and go, oh, I need to get a common denominator. No, you don't. You're not adding or subtracting. So math is the same way. We need to recognize. So let's recognize this as division. So that means we're going to keep, change, and flip. So keep means 4 over x minus 4. We keep it. We change this to times. So I'm going to make an exaggerated dot there. And then here we're going to flip it. 7x minus 28 over 40. So now we have changed it to multiplication, and now we simply, we factor, 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 and factor if we can, and then we divide out. All right, so here, can we factor 4? Nope. So let's come over here. We got 4. We can't factor it. Can we factor x minus 4? Nope. So we put x minus 4. Can we factor, I'm going to change colors because we can factor this one. How can we factor that? This is going to be times 7 is my GCF, right? And what's left? X minus 4. And then can I factor this right here? Nope. Can't factor 4. Just leave it 40. So now I come back and say, okay, does anything divide out? Well, look, I have everything factored. And look, it's also understood. This is understood in parentheses because it is the entire denominator of a fraction. So let me say this here at this point, because on this kind of stuff here, if you write slanted fractions, it's a train wreck. Okay? I tell my students from day one, any class they take with me in algebra or any math class, I say, if you write slanted fractions, I say don't. Just don't. Just don't. Because if you don't put parentheses around things here, for example, if you wrote this, let's just talk about this. If you wrote this, you really just wrote this. And I don't care. You can argue with me. I've been doing this for 20-something years. The only thing you write when you write this is this. There's no other way it is. If you wanted to write this here, you should have written it this way with parentheses. Without the parentheses, it's wrong. And so I guarantee you none of you are taught to write it with parentheses. And if you have teachers who write it slanted and they don't use parentheses, they really should tighten that up a little bit, because that's why math is so confusing, because it seems to change rules every 5 minutes. All right? So teachers out there, help us out, okay? Help us out. So let me take this off here. So if you write slanted fractions, my advice to you is don't. Just don't. Teacher, student alike, don't. Because if you're a teacher, you might know when it's okay and when it's not, but you're just confusing students. And sometimes slanted fractions are okay, but again, anything in math that's okay sometimes and not others is too confusing. It's more confusing to figure out when you can do it and when you can't than just to do it one way all the time. So I will always write horizontal fraction lines that extend fully, and everything in the top's in the top and everything in the bottom's in the bottom. So you know my numerator and denominator every time, undoubtedly. Never a question, no ambiguity. So here, if I look at this 4, does the 4 divide out? Well, look, this is 2 terms, so you cannot divide it out with that. But this is 1 term. So those 2 things can be divided out. So then 4 and 40 can be a 1 and a 10, right? 4 goes into 4 once and 40 10 times. So far, I'm left with a 10 in the bottom, in the denominator, right? So keep going. I like to work my way across the top or the bottom of something. So I work my way across. Does the 7 have anything it divides out with? No. So I keep my 7 up top. Then I get to the x minus 4, and guess what? That's the same thing. And it's like it's in parentheses because it's the entire fraction, denominator of a fraction, because there's a time sign separating from the next one. That divides out. And I am simply, and I have nothing else left down here. I've worked my way all the way across the top. So I'm simply left with 7 over 10. And that won't simplify, so that is my final answer. But look, don't tell me this doesn't have restrictions. You needed to find restrictions up here before you ever started. Okay? You needed to find those restrictions up there before you ever started. Now, I didn't do it here, but that's when you would find them. So if I look at the next problem, what am I doing? I got to recognize it. I am dividing. So if I'm dividing, I'm going to keep, change, and flip. So I'm going to keep 3m squared minus 5m over 3m, oh my goodness, plus m minus 10. And then times m squared plus 6m plus 8, right? I'm flipping this one. And m squared plus m minus 12. So I'm flipping that one. Keep, change, and flip. All right. So now I have to factor each one of these. And if I look at this, there's a common factor here. This one is 3 terms with not a 1 in the front, no GCF. That's bottoms up. That's what I call it, bottoms up. Over here, this is list method, and this is list method. 3 terms, no GCF, and a 1 in the front on both those. That's why they're list method. So you need help factoring. Look for those videos, and they should help you out with factoring those things. So here, this one's going to be fun. I'm going to factor this in yellow, okay? So let's come down here and let's just start with this. That's 2 terms, and there's a GCF, all right? Again, I got to recognize what it is. If I don't recognize it, it's going to look silly. Okay, so it's a GCF. The thing in common is m, and I'm left with 3m minus 5. Okay, extend that out a little bit more because the bottom one's going to be longer. Down here, I'm going to factor this one in gray, and that is 3 terms. I already said it, no GCF, and this is not a 1, so that's bottoms up. So since it's bottoms up, I'm going to take the 3. I didn't leave myself a lot of room for this. I'm going to do this one in gray. So I'm going to take the 3 times the 10. All right, so I'm going to come out here in a thought cloud and do my bottoms up, okay, because that's what I always do because it's not equal. This is not the same thing. I'm not done. So it's m squared plus m minus 30. But even though it's not equal, it helps me solve it. That's very rare in math that you can do that. But this trinomial that I just wrote down is not the same thing as the other one, but I can solve it this way. So I transformed it into a list method because there's a 1 in the front. List method is super easy to factor. So then I want the factors of 30, 1 and 30, 2 and 15, 3 and 10, or 5 and 6. I always like to do 1, 2, 3, 4, 5, 6, whatever. So the factors of 30 that subtract to give me 1, what are they? 5 and 6. 6 minus 5 is 1. So m and 6 and m and 5. And the signs are different. The bigger number gets a plus. So 6 gets a plus and they're different, so 5 gets a minus. Right? If you subtract, you only subtract things that have different signs. So I know they're different. And then I go back and say, look, I multiply by this 3. I've got to divide by the 3. So I've got to divide both of these by 3. 6 over 3 becomes a 2. So that parenthesis becomes m plus 2 because there's a 1 and nothing there to move up. 5 and 3 don't divide out. So that's where the bottom comes up, and it comes in front of this m in the parenthesis. So it's going to be 3m minus 5. All right? So now I've got that one factored. Now these other two are going to be a lot easier. This one's in the pink or the fuchsia here. Okay? So factors of 8 that add to give me 6. Well, 1 and 8 or 2 and 4, and it is 2 and 4 indeed. 2 plus 4 is 6. So m and 2 and m and 4, and both positive. That's what that says. So plus and plus. And then use this little blue here. I want the factors of 12 that subtract to give me 1. So then that's going to be 1 and 12, 2 and 6, or 3 and 4. 4 minus 3 is 1. So we're going to put in here m and 4 and m and 3. And I did that, bigger number first here, or second here, bigger number first here on purpose. It doesn't matter if the bigger number goes first or second. What matters are the pluses and the minuses. So here, this says the signs are different, and there's a plus for the bigger number. So the bigger number gets a plus is how I read it. In my mind, I say different, and I say bigger number is positive. Which one's bigger, 4 or 3? 4 is bigger. He gets the plus, and the 3 gets a minus. And now I'm finally ready. I have all this stuff multiplied together, so anything in the top, the numerator, can divide out with anything in the bottom of the denominator. So the yellow and the pink, anything there, they can't divide out with each other, but they can divide out with anything in gray or blue. Okay? So if I look for m, is there any m down here? Nope, there's not. What about 3m minus 5? There it is. So guess what? Those are gone. Okay? Those are gone. What about m plus 2? It's also gone. Look at that. So boom, because of this multiplies why I can do that. If that's a plus or a minus or something else, I cannot do that. But because of that times, I can do what I just did with the m plus 2s. M plus 4, guess what? There it is, gone, gone. And then I'm done going across the top. So what's left over? I have an m and I have an m minus 3. So the m is in the top, the numerator, and the m minus 3 is in the bottom, the denominator, right? So there's my final answer. Can I cross those m's out? Nope, m minus 3 is 2 terms. You cannot divide a single term out of 2 terms. So m over m minus 3 is my final answer. Okay? M over m minus 3 is my final answer there. All right, so let's keep dividing these things. Let's see what we have here as we divide them. Oh, this is a big one, right? But look, it's a little different. It's a polynomial that's not a fraction divided by a fraction. You still keep, change, and flip. Keep, change, and flip. Anytime you are dividing by a fraction, it doesn't matter. The first thing could be Mickey Mouse or Minnie Mouse or a Mack truck or a baseball. It doesn't matter. So keep, change, flip. So we're going to keep x squared plus 4x minus 5, and we're going to change it to times, and we're going to times and flip it. X plus 7 is now in the top numerator, and x squared minus 25, that's not 25, is in the denominator. Okay, so we kept it, we changed it, and we flipped it. And then I want to remind myself, hey, wait a minute. I have a fraction times something that's not a fraction. This thing that's not a fraction is over 1. Okay? unless your teacher says, what is it understood to be over, you will never answer over 1, okay? I can't think of a time when you would answer over 1, but we need to remind ourselves here it's over 1, and we also need to factor this one and factor this one, okay? So we're going to come down here and we have this thing over 1 times the next fraction, right? So let's factor this one right here in green. So again, this is 3 terms, list method, factors of 5 that subtract to give me 4. What are they? It's going to be 1 and 5, isn't it? That subtracts to give me 4. So x and 1 and x and 5. And the bigger number gets a plus. That's how we read that. So 5 gets a plus, 1 gets a minus. And then over here, we cannot factor this one, so just bring down x plus 7. And then how do I factor this one? Well, that's difference of squares, right? So it's going to be x and x, right? 2 terms. That's a recognition piece. 2 terms. There's no GCF. And then I ask myself, minus sign, perfect square, even power. So that's difference of squares, okay? So then 5 and 5, 1 is plus, 1 is minus. So now I have everything factored. Now I'm ready to go crossing stuff out. X minus 1, is there anything to go cross it out? Nope. X plus 5, right here. So guess what? Those are gone. X plus 7, nothing. So I am left with now x minus 1 and x plus 7 that are both in the numerator. And even though this x plus 7 is not in parentheses, look, it's the entire numerator of this fraction. So it's understood to be in its own parentheses. That's the other good thing about writing a fraction horizontally. This is understood to be in parentheses. This is understood to be in parentheses. And the whole thing is as well. That's the way every fraction is, by the way. All right? But when you write this horizontal fraction, you guarantee that it's not misunderstood. When you write the slanted fraction, you need the parentheses there because it's not quite right. All right? So then this is going to be x minus 1 times x plus 7 over, and the only thing down here is x minus 5. I know the 1 is left, but if I take 1 times anything, do I write the 1? No, don't write the 1. So there it is, x minus 1 times x plus 7 over x minus 5. All right. Last one of these. And again, what are we doing? We are dividing. So that means we are going to keep, change, and flip. So we're going to keep p squared minus 4 over p squared plus 3p minus 10. We change 2 times, and then we flip it, right? Flip this thing upside down. So p squared plus 8p, right? The 8p one goes in the top. That's enough to know which one, right? Because this one is p squared plus 5p plus 6, and it goes in the bottom or denominator. And then after I do that, all right, then I'm going to come back and factor all of these things. So let me go ahead and put my fraction lines here so I can factor them. All right. This is how many terms? 2. Is there a GCF? Nope. Is it difference of squares? Yep. Right? Even power minus and a perfect square. That's what tells me it's difference of squares. Okay. So then we have p and 2 and p and 2. One of them is plus, one of them is minus. Then we say, okay, let's come down here. This is 3 terms, no GCF, with a 1 in the front. So that's list method. So then that means it's going to be p and p. Factors of 10 that subtract to give me 3. Well, there's only 2 choices, 1 and 10 or 2 and 5. 2 and 5 give me 3. So put in here 5 and 2. Or 2, it doesn't matter the order. What matters is plus and minus. Different signs. Bigger number gets a plus. Bigger number's 5 gets a plus, 2 gets a minus. And then we move over here to this one. 3 terms again, no GCF, 1 in the front. This is list method again. List method is one of the faster ways to factor. That's why I put several of them in here. Factors of 15 that add to give me 8. Well, it's going to be 1 and 15, or it's going to be 3 and 5. And 3 plus 5 is 8. So put in here 3 and 5, or 5 and 3. The signs are the same, so I read it as both positive. In my mind, I say the same, and then I read it as both positive. And then finally underneath it in the pink or the fuchsia here, we're going to do P and P, right? Because again, this is my list method. Okay. Sorry, something was on the screen there. This is my list method. 1 and 6 or 2 and 3. That's the list I'm making of my factors. The ones that add to give me 5, what are they? 2 and 3. See, don't do 6 and 1. That subtracts. So here, 2 and 3, and they're both positive. Both positive. So P plus 2, guess what? It's gone. It's gone. Boom, gone. And just to be more colorful, I'm going to use more colors. P minus 2, there it is right underneath it. It's gone, right? So that's gone. Divide it out. Boom. Then we come over here and we say, okay, what about P plus 3? It's gone. Look at that. Gone. And then I have one more thing to check in the numerator, P plus 5, and guess what? There it is. So it is also gone, right? So if everything divides out, notice I didn't say cancel here because it doesn't cancel. We were taught that. I was taught that. Your teachers were taught that. Most math teachers just don't look at the book they're using and don't realize it's not there anymore. But it's not in any book that I have that's less than 30 years old. So this is, everything is gone. It's 1. If it canceled, it would be 0. When things cancel, if I have $5 and I go to the gas station and I spend $5, guess what? I just canceled the money in my pocket. Because 5 minus 5 is 0. Got none left. Okay? But if I divide, everything divides out. Every one of these things becomes 1 when we divide them out. And what is a whole bunch of 1s times each other? 1. And what is 1 over 1? 1. So that's just a fancy way to write 1. All right, so I hope this helped you out with dividing these fractions.